Okay, so as Morten suggested, I'm going to talk about scripting in Dyalog 18.2. Now, I spent quite a lot of time talking about this last year, so I'm not going to go into too much detail about what scripting is, but there will be a little bit of a recap of what we're talking about. And then I'm going to spend some time talking a little bit about what has changed since we had a similar presentation last year. And then I'll talk about what's likely to be different by the time we have a similar presentation next year. But what we mean by scripting is fairly consistent. I like to call it hash bang scripting. Those two characters, the hash and the bang, make me want to call it hash bang scripting, but Morten referred to it as shebang scripting earlier. He also referred to it as shell scripting earlier. But essentially, we're talking about text files that can be executed from an interactive terminal using the standard mechanisms that are available there in terms of input and output and so on. We'll talk more about that in a while. Why we would want to do this is so that we can use APL alongside other languages that exist in a similar infrastructure. And it also means that we can use APL code sort of in a pipeline. We can feed the output of one bit of code into some APL, and we can feed the output of that into a third thing. Scripting then on Windows, we might use batch files to do scripting, and here on the right hand side is we have a sample of a batch file. On Linux, we might use Bash as our script language, and on Linux operating systems, the type of code within the file is indicated by this special comment at the top of the file, and here we see the hash bang characters that give the name hash bang scripting to these things. On Windows, we might also use PowerShell scripts for scripting, or even VB scripts for scripting. But now we can add APL to this list of languages that support this scripting. And with an APL script, we have this hash bang statement at the top to indicate that this file contains APL script information. This line here is of no interest except on Linux operating systems. On Windows, the determination that a file contains either batch script or PowerShell script or Bash script or APL script is typically done by its extension. A lot of the stuff, as Morten mentioned, that gives us the hashbang scripting in APL is made possible by the extended multi-line session input that we introduced, I think, in 18.0. I'm not going to talk about that anymore at all, I think. So before I go further on in the PowerPoint, I just want to give you a few examples of these shell scripts. Hopefully, as I rotate my screen, we can now see a Windows desktop. And on the right-hand side here, we can see a batch file, and I can right-click and I can run the batch file. It asks me to enter my name. I can do so, and I get a response back. I also have here this hello script written in APL. I can right-click on here. I can run this. It asks me for my name, and I get a response back. Shell scripts typically operate within a terminal. Okay, you can use shell scripts to produce GUIs, but typically there are better ways to do that. So we will generally use a script where there is some level of terminal-based interaction with the user. It's convenient that we can start the scripts from the Windows Explorer, and we can preview them and we can edit them from here as well. But generally, as I say, we're going to be interacting with these scripts from a terminal. So we might have a Windows command line, Windows command prompt, and in a Windows command prompt, we can run a batch file. Okay, here we're not getting the extra pop-up because everything's happening within the terminal that I'm already inside. We can do the same thing on the Windows subsystem for Linux, and here we can run the APL script there. Many of us at Dyalog on our Windows platforms use a thing called Cygwin, which is a thin Linux shell. that sits on top of Windows. So it's not part of the Windows subsystem for Linux. It's just a bunch of native binaries that run on Windows. And under Cygwin, we can do the same things. But this is the environment that I tend to sit in when I'm working on the interpreter. Oftentimes, I might use a Linux command called grep to search for text within the source code of the interpreter. Unfortunately, that Linux utility doesn't allow me to search for text within a Dyalog workspace, for example. So what I have here is I have a wasgrep APL script, which contains some APL code. Okay. And a couple of functions, some expressions at the bottom. But this allows me to, from my traditional development environment, grep for a particular expression inside, for example, all of our QA workspaces. Okay, and again, that's interacting with the terminal, and it's giving me all of the locations in all of our QA workspaces where the phrase windows.forms is used, and I can run the same expression on a Linux shell. Here I'm looking for quad using. I can even run these scripts from an interactive session. I can use parensh, quadsh to run an APL script from within my Windows session, and there we get the output. Nothing is happening in the workspace here. What's happening is there's a separate APL process that spins up in the background, but we get the output from that, and that gets displayed in our session. Okay, both with parensh and quadsh. You may notice here that I search for quad using. We don't see quad using. There appear to be some encoding issues with the output, which we are hoping to address. So those are the sorts of script files that we're talking about and the contexts in which we can execute them. So let's come back to the PowerPoint. Okay, so what's changed since this time last year? I mean, not a lot, but a number of useful things. First thing is we've changed the file extension from Dyalog script to .apl just to be a little bit more concise and a little bit more descriptive of what's inside the file. This really doesn't have any bearing on anywhere other than Windows. It's only on Windows where the file extension is used to associate it with an action, for example, in the Windows Explorer, as we saw. And we've made a number of small tweaks and fixes, obviously. We're always doing that on various bits and pieces inside the interpreter. And hopefully we'll add more samples between now and when 18.2 goes out. But let's look at some of the changes that we've made in the context of the code that they run in. One of the things we've changed is default output. If you have a script that does nothing with the result of an expression, that will no longer be used as output for the script. Okay, that won't appear in what the user sees as your script is running. In order to get output from your script visible to the end user, you need to assign the result to either quad or to quote quad. Trivial change, but it means then that you can be a little less cautious about how you write your code, because the users are only going to see those results that you specifically want them to see. Something else that we've changed is how the interpreter that runs these scripts is configured. We felt that we wanted this to be a little bit more black boxy. We didn't want the behavior of your script to be affected by an external setting of maxwas that a user might have set for something else. Or we didn't want the behavior of your script to change because the user might have set wasPath to some value which wasn't appropriate for your script. So APL script files no longer pick up their configuration settings from the environment or from Windows on the registry. Instead, if you have a script and you want to configure it, and here is just a simple script that interrogates the maxwas and the thing is running under and returns the actual workspace that's available. If you want to configure the maxwas that this script runs on, then you can put the assignment to the maxwas value on the command line within your script file. So it's nice and local to your script as you write it, and you can be sure that that's not going to be overwritten externally by the user. Alternatively, if you have your script in a file, for example, in this case called maxwas.apl, if you have a companion configuration file named for the same first part as the script file, maxwas in this case, with a DCFG extension, then the configuration for how this script runs will be taken from that configuration file. So it's a nice enclosed system that can be configured either within the script file itself or externally via these text files. And so if you did have end use configurations that you wanted the end user to configure, then they can change the configuration file perhaps. They don't need to look at the actual code that's doing the work. Another small change that we made is we've changed the behavior of an APL script if an error occurs inside the script. Here, for example, we have a line of code that quad div aside will generate an error. At runtime, the following line of code will not be executed. In fact, all subsequent lines of code won't be executed. The script file will exit as it hits that divide by 0, and it will exit returning a non-zero exit code to the calling shell. Generally, non-zero exit codes have special meaning. A 0 code would mean the thing finished okay. There are many exceptions to that, but broadly speaking, that's what we use the exit codes for. Okay, so I'm now going to spend some minutes talking about the biggest change that we've made to the scripting. But first of all, I want to explain a little bit about why it's necessary. So I want to talk a little bit about debugging these scripts with either the original development environment or the remote development environment that Morten was talking about before. A few words are, well, it's tricky. It's so tricky that it doesn't work yet, but we are working on it. I'll explain a little bit about why it's tricky. It's because there's a whole lot of I/O going on. Okay, if we have a script that looks like this, which asks the user for input and generates some output, if we were to run this just in the traditional development environment, then all of the code, all of the input is read from what we've typed into the session. All of the output is written to the session. Everything is typed into the session. The code is read in the session. The responses to the quote quad prompt is typed into the session. Everything's always in one place. Similarly, if at a terminal we were to redirect input into the session, for example, hello.txt could contain our APL code, okay, then all of that input is read from terminology, from std-in, standard input, i.e. The result of this command called cat, which is concatenating the text that's in the file. So all of that gets read into the interpreter, but then the interpreter has difficulty deciding which of that is code that should be executed and which of that is the result of the request for input. This, for example, is going to get confused when it gets to the out quote quad. It's going to take the next line of that file as my input, and I as a user has no way of typing that input in, so that this becomes a very closed system. However, if we're running this thing as a hash bang script, then the interpreter is running in a different mode and it can distinguish between these different types of input. And what happens is when the interpreter spins up this script, the first line is read from the file and then it's just ignored. It's got this hash bang at the front. The interpreter knows that, okay, once I've got this far, that's of no interest to me. That's an indication just to the operating system, to the non-Windows operating systems, to tell it how to run this script. This code then is read from the script file and executed using the extended multi-line input of the session. This code is read from the script file and executed in the session. But then we get to this in-string quad get stuff. And what happens now is that the interpreter will write this to whatever the user output is. And in the examples where I've typed this before, that's just appeared in the terminal. But it could be written to the standard output stream, which we call stud out generally, and that then can be piped to some other command in the pipeline. So yes, so enter your name has gone to stud out. Then we get to this quote quad, which is a request for input. Now, when we're running this as a script, this input needs to be read from whatever the current user input is. Typically, it'll be the terminal. So we will be asking the user to type this. Importantly, it's not read from this code. We are separating the input that is the code that is to be executed, and then what is the user input into the application. And then we have the same issues. You just press enter to continue, gets written to user output to stud out. And then the quote quad input here again is read from the interactive user input. We're expecting the user to type this. So this I/O that's going on is very different in the cases that we're talking about. In the traditional development case with the ODE or with RIDE, all of the input is coming from the session. Okay, and similarly, if we pipe our stud input into the interpreter, all of the input for the interpreter has to come from that one place. With hash bang scripting, then at runtime, well, we want the code that's to be executed to come from the content of the hash bang file, but then the user input is going to come from quad or quad in or quote quad in, and those will be connected to these standard streams stud in and stud out. And generally speaking, these may all be different. Stud in may be coming from a different place to where the code is coming from, obviously. And our output from quad might want to go to somewhere differently to our output from quote quad. So we have these conflicting sources of I/O and destinations for I/O. When we add a debugging layer to this, it's even more complicated, because when we want to debug a hash bang script, then depending on what we're doing, we want something from one of these first two columns to happen. We either want to get our input from the development environment so that we can look at our local variables, fix our code, see what's going on, or we want to get our input from the user. We want to go back to the terminal and get the user to get user to type the response to the quote quad input. Typically, if there's an error in our script, then as the debugger is attached, we want it to switch into one mode or other. But then as we're developing the application, we're going to want to switch where our input and output comes from. And it's for those reasons that it's difficult, and we're working on that. I've got some a checkout of version 19 where I've been experimenting with new ways of handling this I/O so that this becomes easily configurable at runtime, so that we can change where our input and output comes from. So to get these things debugged from RIDE is difficult, but we're working on it. In the meantime, then, let's take an idea from Bash. Bash is the scripting language that is typically used on Linux, but is also used in the Cygwin terminal that I mentioned that a lot of us at Dyalog use for development. So Linux has this thing called set-x, which we can say is -x. We can abbreviate that to mx. Mx is Roman numerals for 1010. So let's have a 1010 I-beam that does a similar job to set-x. Here is a bash script. It contains some code. If we just run this script as it is, then this is the output that the user will see after having typed John D in the middle. If we put a set-x in our script, then this switches on an element of verbosity. And when we run that, we get not only the output from our program, but we also see in bash the lines of code in our script as it's being processed by the shell. In batch scripts, there's a similar thing, except in batch files, this sort of works in the opposite direction. Typically in a batch file, if you don't want that output, you have to explicitly tell the batch to don't echo the input as it's being run. But for our APL scripts, we're going to follow the bash model. So in bash, we have set -x. In an APL script, we're going to use this 1010 IB. I hope this font is okay. Full stop. I hope this font is okay. I can't do anything about it now. If we have a 0 argument to 1010 IB, then that just means run the program, just do the default thing, don't spit out any additional diagnostic information. If we use a 1 as an argument to 1010 IB, then this works very much like set -x, and we get in our output, we get our code as it's being fed into the interpreter, prefixed with this plus character, which is what we saw on bash with the set -x. Then we also see the output from our actual program as we go through. APL programmers, I know, might be very used to having a 6-space prompt for their code and no prompt prior to their output. So 1010 IB can take a left argument, which is the prompt to use as it is outputting the code that it has read from the script. So this gives us something that looks much more like the what we would see in a session if we typed all of this stuff interactively. Okay, so that gives us equivalent behavior to set -x in bash, and is a useful way of seeing dynamically as our application is running what's going on, given the absence of the ability to connect a debugger to the thing. But we can go one step further with APL. If we have an argument 2 to 1010 IB, then what the interpreter will do is it will actually switch on quad trace for every function in the script as it runs it. And we get the information that those of you that have used quad trace will be familiar with. It gives us the name of a function and the line of a function as it executes it, and also it's not necessarily the result of each line as it runs it, but I'm not sure what the terminology is, the most recent thing that was evaluated, even if it was subsequently assigned. Okay, so for example, t size 1, we see whatever was assigned to A, even though normally that would be quiet because the assignment would consume the argument. And these two values that we've got, the 1 and the 2, can be combined. So if we do 1010 IB in 3, then we get both the quad trace output and the indentation of our code as it comes in. So this gives us quite a static but a useful diagnostic way of interrogating our script as it's running until we get to the point where we can connect an actual debugger to the thing. And in fact, I think this has merit anyway, even when we're able to connect RIDE to a script that's running. I think there's a lot to be used for this sort of low-level diagnostics when figuring out what's going on with the script. So that's what we're doing to make it slightly easier to debug these APL scripts. Now, I'm just going to end with a couple of things that that you can do with bash and you can do with batch files, but that we don't quite do either at all or in the same way. Alongside set -x in a batch file, in a bash script, you can have set -e. Now, set -e affects the error behavior of a bash script. Here is some APL code where I said the divide by 0 generates an error, and therefore the rest of the code won't get executed. In a bash script, you need to set -e in order to get that error behavior. So with set -e enabled in this bash script, okay, if that generates an error, then the subsequent lines of code will not be executed. Okay, by default, without set -e, bash will allow all of the script to run even if an expression within it generates an error first. We sort of decided from an APL's perspective that that was, I don't want to say dangerous, but possibly a little bit foolhardy to say, okay, well, something didn't work, but we'll just carry on anyway, regardless, hoping that everything works. So there's a thought that maybe that we could use a value of 4 on the 1010 I-beam to control this error behavior. Okay, maybe we could say that if you do 1010 I-beam 4, then even if a line of code in the APL script generates an error, then we would carry on. Okay, but we haven't done that, but it's something that we might want to do in the future if the feedback is such that, you know what, there are cases where we do want to carry on even in the event of an error. What I would suggest now, of course, is that without that setting, just put a colon trap around everything and handle the error within the script appropriately, which is probably the most sensible thing to do anyway. And then finally, the other thing that Bash is very good at is calling script files from within script files. Here is a Bash file, which basically is going to call a subscript called hello.bash twice. And each time we do this, the hello.bash is run in a new process and we get its output. We run the second one and we get its output. Bash also has an option to prefix a command with a dot like this, and there's a command name as well to do this, which dot is an alias of, but I can't remember it, so let's just go with dot. And this is slightly different in that it runs the scripts within the same process. Okay, so within the same environment and so on. Source, thank you. Torsten in the chat has just, in the Q&A has just said it's the alias is source, thank you. So the analogy here would be that if these were APL scripts, that these would run inside the same workspace. Okay, so any variables that were in the workspace would be available to these scripts. It's difficult for us to do that at the moment, so we're not there yet. We can in APL use parensh or quadsh, of course, just to run the scripts in separate processes. And that sort of, generally speaking, works. I did it with parensh with the wasgrep earlier on, and that worked fine. But there are issues where the I/O gets in the way, where if a script is running this way and asks for input, we've got some issues because we're not entirely sure where to get the input from. So that at the moment doesn't work, but it's something that we're looking at. We may be able to fix it in quadsh, but it's hard to know how to get this case where we want everything to run inside the same process to work with quadsh without adding variants and other nastinesses. So my feeling is that most likely we're going to need a new mechanism to be able to get scripts to run from scripts. So that's essentially where we're at. What we're hoping to change by this time next year is to add the ability to debug with RIDE, and add the ability to have scripts calling scripts. Then that will require us to address the I/O issues that I've just mentioned. We're hoping to produce more samples, and then, you know, what else is missing? What else do you think would be useful here? I mentioned the 1010 I-beam 4 to change the error behavior. Is that a good idea? Maybe there's other things we could do. What else do other scripting languages give you that might be useful? You know, what else might we need to do? That's it. That's where shell scripts were, where they are for 18.2, and some indication about where we'll take them in version 19. I have gone 1 minute over. So, but I'll hang around in the chat and I'll take any questions in the chat. If there's anything important that Morten wants to shout out now, then I'm happy to take that.
Nope, I don't think so. You started 1 minute late, so that's fine.
Brilliant. Okay. Well, as I said, I will be in the chat. So if there are any questions, then ask them in the chat now. And obviously I will be around in various chats and open sessions later if anything comes up. Thank you.